All right, so we're going to go through an example of how we perform a chi-square test for homogeneity. Homogeneity, and that's essentially when you want to determine if a set of data or distribution varies from what is claimed. But let's go through this example because it's going to make a lot more sense. And like usual, there's conditions that you have to check, pretty similar to like the conditions you've been using for significance tests so far. The random condition, make sure the data come from independent random samples or from groups in a randomized experiment. 10%, make sure you take no more than 10% of the population when sampling without replacement. And the large counts, make sure all expected counts are at least 5. All right, so going back to this scenario where we have the distribution of Facebook use on the main campus versus the Commonwealth campus. And we're asked if these data provide convincing evidence of a difference in distribution of Facebook use among these two campuses. So it breaks down step by step how you should set up your significance tests. So let's go through it. So part A, we're going to state first the null and alternative hypotheses. So all our null hypothesis, or HO, or HO, will be, that there is no difference in the distribution of Facebook use among the two campuses. So there is no difference in the distribution of Facebook use among the two campuses. And the alternative is essentially saying that there is a difference in distribution of Facebook use among the two campuses. So there is a difference in the distribution of Facebook use among the two campuses. Okay, so we're now going to calculate the expected counts. So let's think about this. Remember, the expected counts is what you would expect your values or your counts to be for each of these 1, 2, 3, 4, 5, 6. What you would expect those 6 numbers to be if the null hypothesis were true. So if there was no difference in distribution of Facebook use among the two campuses. So we have to figure out what would be the null hypothesis proportion. So the way we want to think about this is let's first total up each row so we can see more easily what's going on. So first row, these add up to 131, 215 and 157 add up to 372, 640 and 394 add up to 1034, and the total adds up to 1537. Okay, so if there was no difference in the distribution of Facebook use among these two campuses, then we would have that the same proportion uses Facebook several times a month or less among each campus. Now that proportion would be found by taking this total and dividing by this. So 131 over 1537. Let's do that right here. And that's about 8.523%. Now, if we assume there's no difference in the distribution of Facebook use, that means that about 8.5% of students use it several times a month or less among each campus. So you want to calculate what is about 8.5% of the total in each campus. And so you would basically take this number and multiply it by that, and you would get the expected counts here. And you would take this number and multiply by that, and you would get expected counts over there. So let me break this down like over here, because usually you'll see a form given like, you know, the expected counts, the row total equals times the column total over the table total. But it's important that you understand it, because you don't want to just memorize that and not really get it. So this value, that's the proportion, 131 over 1537 multiplied by 910, and that'll give us this number. That'll give us this expected counts up there. Calculating, we get let me use a different colored pen. We get 77.56. So this would be 77.56. And then we do this proportion times 627. So our other one would be 131 over 1537 times 627. That'll give us the expected counts for the Commonwealth campus. And we would get about 53.44. So there we would have 53.44. And that logic applies for the other 6 values, or for the other 4 values. So for the proportion that would use Facebook at least once a week, if we assume that there is no difference in distribution, you would take this number divided by this, that'll give you some percent, and you multiply this per proportion by 910. So it'll be 372 over 1537. Multiply by, again, 910 for that one. We get you got a bigger 220.25 right here. And then to find the expected counts here, you would take that proportion, 372 over 1537, and then multiply it by 627. We would get 151.75. And the last two, to find the expected counts for these 2 values, you would take this total, 1034 over 1537. That'll give you some proportion. And likewise, you multiply it by the total number of students in each campus. So this times 910, we get 612.19. And then we go 1034 over 1537 times, not 910, which times 627. And we get 421.81. So that's the logic behind that. So make sure you understand that. And and just don't resort to memorizing the formula, because you could always forget the formula, and then if you don't understand it, you won't know if your formula is wrong or not. Okay, so all our expected counts are at least 5, so we're good there. Now let's calculate the chi-square statistic. So remember, this is simply, the sum of the observed counts minus the expected counts squared over the observed counts. So remember, observed minus expected squared, or I'm sorry, I mean over expected for each of the values. So for the first one, we would have the observed would be 55 minus 77.56 squared over 77.56. Plus the next one would then be the 53.4, or the 76 minus 53.44 over 53.44. Plus this observed, or the 215 minus 220 squared over 220.25 over 220.25, plus this, observed minus expected squared over expected, and so forth. So I'm just going to go ahead and jump ahead, and so that way I don't waste time in the video, doing this tedious calculation. But go ahead and make sure you do it on your own so that you get the correct answer. And you should get about 19.49 for your chi-square statistic. Okay, now let's find the p-value, and let's use our calculator's CDF function and the formula sheets, as usual, but I eventually it's gonna not be necessary. But in the formula sheet, remember, we look over here, degrees of freedom would be 1 less in the rows times 1 less in the columns. So remember, rows minus 1 times 2 minus 1, so 2 times 1, so we get 2. 3 rows, 2 columns. And looking at table C, we go to degrees of freedom of 2. When we look to see where we have the closest to 19.5. And this is going very extreme, so it's already past that. So the p-value is going to be already far below this, or not far, maybe not far below this, but definitely below this. So we get a p-value of less than 0.0005. In our calculator, you can go to the distribution function, press vars, and go to chi-squared CDF. Remember, it's the lower bound, 19.49, comma, upper bound, make a huge number, comma, degrees of freedom, and you get a super small value. P-value of about 0 again, so 0.0000585. And let's draw a visual so we don't forget what this is showing. Our chi-square distribution. We're looking at the area to the right, always. So this p-value or this area would be like this value, which is super small. It's not even like a tenth of a percent. Okay, so what does this mean in context? Like this is basically a value that tells us the probability that we would get data this this unique, or that you would get the difference this big if the null hypothesis were true, meaning that if the two distributions were the same. So let's write that. So if we assume assuming that there is no difference in Facebook use among two groups, there's about like a 0% chance, essentially. There is about a 0% chance that we would get a difference this great or greater by luck alone. And because of that, so following up with our last part F, because of that, our conclusion then would be part F, E. Our conclusion is that we're going to reject our null hypothesis because our p-value is far less than our alpha of 0.05, and we say we have convincing evidence that there actually is a difference in Facebook use among these two groups. Since our p-value is less than our alpha of 0.05, we reject HO and conclude that we have convincing evidence that there is a difference in Facebook use among the two groups. And there should be that there is a difference in Facebook use among the two groups. All right, so that's all there is to it. So I hope that helps. Good luck.